The next topic which we are going to see is data frames. Data frames is somewhat expanded form of series. So in series, we had only index values corresponding to the data in the series. In data frame, we associate the data in form of a table. So as it is in form of table, it is associated with the row values and column values. So it is similar to a spreadsheet or a table. Okay, so there are three important components which corresponds to data frame. The data, actually this is what is actually stored in form of table, and row values associated with the data, and the column index values associated with the data. So these are the three main components of data frames. Okay, so we can see an example here. So in this table, we can find out all these data, right? Very broadly, likewise, all these data in greens and whites. So they are one of the component. Okay, so we have column names, right? Name, team, number, position, age. So all of these are considered as column names or column index. Similarly, we have row index or row names like 0, 1, 2, 3, 4, 5, 6. So all of these components together, the rows, the columns and the data, all of these together forms a data frame. So we can see an example for data frames. Okay, so see, we are having a data. So we are going to now create a data frame using values from the dictionary. So dictionary here in the sense, okay, so what happens for the title name, you have all these John, Alice, Bob. Age, you have these three values 25, 30, 35. And city, you have New York, Los Angeles and Chicago. Okay, so we are converting this dictionary data into a data frame. So if we print this data frame, it will be printed like this. So what happens? You will have name. Okay, next one as age, next one is city. Okay, so name is John, Alice, Bob. So that is placed. Next one is 25, 30, 35. That is kept here. And New York, Los Angeles, Chicago. All these are placed here. Okay, so this is the data frame that is being created by means of these commands. Now, we are going to create the data frame from list of lists. Okay, so which means what happens? We are giving all the data like this as list. Okay, John 25 New York, Alice 30 Los Angeles, Bob 35 Chicago. So together we are giving. Okay, so then we are separating all the data in the first, in the list, the first data corresponds to name, and all the second data corresponds to age, and all the third data corresponds to city. Now, if we convert it into data frame, okay, so what happens? If we print the data frame, same thing, your data frame will be printed like this. Okay. So see, what they are actually fixing here is, see, this is the data. All these data, we are giving the column names. What column names we are giving? We are assigning it to columns once again. So what are the assigned values in columns? They are name, age and city. So see, column values are given as name, age and city. Since we do not define any row values here, by default, it takes the value 0, 1 and 2. So next comes the indexing in data frames. As we have done indexing in arrays and series, similarly, indexing can also be done here. Okay, so suppose if I want to print only the names in the data frame, if I give it like this, so what happens? All the three names alone will be printed. So df dot in the data frame, the data corresponding to location of 0. Okay, so we are accessing a particular row by means of giving its label. So if we do so, it will help to print the data corresponding to the location 0. Similarly, we can also access a row by means of integer position. So if we do so, same data in this case will be printed. Okay, so name, age, and city is printed. So suppose in the data frame at the location 0, what is the name that is being associated? So the name associated is John, and that also can be printed here. So next we can move to column operations. Okay, so we can perform arithmetic operation, filtering and sorting in data frames. We'll see them one by one. Suppose if we want to add a new column to the existing data frame, we can add it like this. Okay, so you give df of single quote salary, you give the value. So already existing data frames, this particular column will be newly added. Okay, so if we want to filter the values based on any particular condition, then we can give it like this. So high salary employee is equal to, in the data frame, okay, so data frame of salary, the salary column, okay, whichever is greater than 60,000. So that if we want to print, we can print and see. So this is how you filter values based on any particular condition. Similarly, if you want to sort the data frame either by ascending or descending, okay, we can also do that. So for all of these, we'll see some examples in the upcoming slides. Okay. Okay, so as I have told you, by means of giving this command, what happens? A new, what to say, a column is added with the name salary, and it will hold the values of 50,000, 60,000, and 70,000. So, what happens in the previous data frame, which we have seen? Okay, so now a new column will be added whose values can be 50,000, 60,000, and 70,000. So now I want to print the values where the salary is greater than 60,000. Okay, so see, only case where the salary is greater than 60,000 is for Bob. Okay, because he has 70,000. So only that data alone will be printed here. Okay, so see, the next case we are going to implement the sort. So how I want to perform the sort? I want to sort based on age. Okay, so if I give ascending equal to false, which means in the descending order, in the descending order of the age, the data has to be sorted. So this is the age. The highest age is kept here. After that, next least age, and finally the least age will be arranged. So the entire data can be sorted based on the descending order of the age factor. Okay. So handling NAN. Okay, so we have seen what do you mean by NAN. NAN is nothing but not a number. So how to handle this NAN? Okay, so we have various provisions for handling this missing values. Okay, so we can either drop those values or fill it with some other values. Okay, so the command which can be used for dropping that not a number value is, you can give it as data frame dot drop na. So in the data frame we have created, there is no nan values, hence here none of the values are dropped. But whereas in big data frames, if you have any values associated with nan, so then it can be easily dropped. Second one is, you can even fill the nan values with 0, or replace all the places where NaN is present with 0. Okay, so if you do so, all the NaN values in the data frame will be replaced with the value 0. Next comes grouping and aggregation. Okay, so we can group data what to say, based on any particular condition or operation. Okay, so see, suppose if you give okay, group by city. See, you have to group the city based on the age. Okay, so what happens? See, in the data frame we have created, there were only three cities with different ages. Okay, so what happens if in case you have a data frame wherein you have so many number of people from Chicago, with different ages. Similarly, Los Angeles, so many data, and New York, so many data. So all the ages will be averaged, and the average age can be printed by this particular command. Okay. So next is indexing, fundamental operation for accessing any data efficiently. So it actually involves assigning identifiers or labels. Okay, so what happens? We assign label here. So these are the row index values, these are the column index values, and we have index positions corresponding to those values. Okay, so these are considered as a row index position. So what are the features of indexing? We have three important features of indexing. First one is immutability. So once created, an index cannot be modified. Second one is alignment. So it is used to align the data structures like series and data frames. Third one is flexibility. Pandas offer various indexing types including integer based, data type and custom indices. So these are the features of indexing. So index creation. Okay, so see, as we have done for the series, similarly for this data frame also we can create the index. Okay, so what happens? So this is data equal to name Alice Bob Charlie, age also we have given. So pd.data frame converts the data into data frame, and we are setting the index as ABC. By default, if we do not set that, it will be 0, 1, 2, but here we have created the index values as A, B and C. Okay. So we can also re-index. Okay, so already there is an index present for the particular data frame. We can re-index with a different index. Okay, so for doing so, we require this re-index command. Okay, so you can see here name and age data frame is created and index has been given to ABC. Now you are creating a new index with the values A, B, D and E. Now you are using the command df.reindex with the new index. So for all of these data, instead of having these index values, you will have to reindex with the new index values A, B and D, A, B, D and E. So if you use this command, what happens? A, B, D and E. A, C will be replaced by D, and you have, since you have extra index here, that also will be displayed. But since we do not have any values associated with it, NaN will be filtered. Okay. So dropping an entry. Okay. So dropping refers to removing specific rows or columns from a data set. So this is the most common operation that is being used in data cleaning and pre-processing to handle the missing values, outliers or irrelevant information. Okay, we can see an example for this. Okay, so this is a data frame we have created Alice, Bob, Charlie, and 0, 1 to age 25, 30, 35. Okay, so this is a data frame we have created. So now if we want to draw any one of the column from this particular data frame, for example, if I want to draw in the age column, okay, then if by means of giving this command, this particular age column can be dropped, and after that if I print and see the data frame, what happens, it will be I mean the age column will be dropped and rest of the things only will be printed. So this is how you drop an entry in the data frame. Okay, next one is selecting the entries by means of a position. Okay, so what happens? See here, names are given, age values are given, and city values are given. We are creating a data frame with that. Okay, suppose if I want to what to say, like select and display any particular value. See, in the data frame, the location corresponding to index value 1. Okay, so if you see this created data frame, this is the index value 1 and it corresponds to name Bob, age 30, and city Los Angeles. So by means of giving this command, we can now print only the data which corresponds to this location 1. So we can also do so by means of giving a condition. So see, a data frame is created here. See, in the data frame, if the age is greater than the 30, then print that alone, that data alone. So among these three ages, only 35 is greater than 30, right? So this particular data alone will be fetched and it is printed. So we can select the entries based on the condition also. Next one is data alignment. So data alignment is actually intrinsic, which means it's inherent to the operation you perform. So align data in them by the labels and not by their position. We are always supposed to align the data by the labels. So this particular function is used to align two data objects with each other according to their label used for it can be used for both series and data frame, and it returns new objects with the labels compared and aligned. Okay, we'll see examples for data alignment. Okay, so what happens? We are creating two data frames here. First one is df1. ABC is index values. Okay, so to the column A you have 1, 2, 3. To the column B you have 4, 5, 6, and to the column C you have 7, 8, 9, and 0, 1, 2 are assigned as the row index values by default. Okay, so same way we are creating another data frame. Okay, A, B, D are the column names. 10, 11 for A, 12, 13 for B, and 14, 15 for C. Since we do not explicitly assign any row index values, by default it assigns 0 and 1. So now, if you look at this, if you see, if you give this command df1 underscore align, df2 align equal to df1 dot align df2 fill values np dot nan. Okay, so this means based on the size of data frame 1, you have to align the data frame 2. If the values are not present, please fill the values with NaN. So that is what is given. So size here is C 3 by 3, and we do not have a C index here, but however that will be included, and all the data that is not present in the data frame 2, it is filled with NaN. Similarly in data frame 1, the D column is not present. So we need to align both the df1 and df2. So what happens? The data frame 1 also, the missing values will be filled with NaN. Okay. The next topic which we are going to see is rank. So rank is actually assigning ranks or position to the data elements based on value. So a rank is actually done based on positioning after sorting. So this is actually used if we are analyzing data with repetitive values. Okay, so and if we always wanted to find out the top or the bottom entries, then we go for this rank. Okay, so we'll see an example for this rank. So we are creating a data frame, okay, with the column name animal. Okay, so you have fox, kangaroo, deer, spider, and a snake. Okay, and we are assigning the number of legs as 4, 2, 4, 8, and not a number. Okay, so if you print the data frame, it is printed like this. Okay. So same thing is shown over here. Okay, now you need to create, or if we give the command default rank, okay, so what exactly the thing that is happening, we'll see now. Okay, so see, this is the data frame which we have created, right? So now what happens, all the number of legs, okay, associated with the animals, it will be ascendingly arranged. Okay, starting from the smallest number, then 4, 4, then 8, then NaN. So it is all the number of legs will be ascendingly arranged. Why number of legs is chosen here? Because in the data frame, based on the number of legs, we would like to rank it. So first, the number of legs are arranged ascendingly. Then we are finding or fixing position after sorting them in the ascending manner. Okay, so what happens? We are starting from 1 and assigning position values for each and every sorted number of legs. So 1, 2, 3, 4, 5. We are doing that. Next, we'll have to set the rank for this. Okay, so what happens here, since both are in the second position and the third position, both the values are the same. Okay, what do? We give equal ranking for both of them. So what happens? Both their positional values added and divided by 2. So which will give a equal rank value for equal number of legs. So we are assigning equal rank value for equal number of legs, and then finally 4 is placed in this rank and then 9 is placed. Okay, so now we need to find out the default rank. So default rank means, see, all these we have done as a process to find the default rank, but originally fox number of legs is 4, Kangaroo 2, deer 4, spider 8, and snake in 8. Okay, so what happens? The rank values are once again arranged back based on the number of legs. So what is the value corresponding to 4? It is 2.5. So that 2.5 is placed here. So for 2, it is 1. Okay, so that is placed here. For 4, it is 2.5. So that is placed here. And for 8, it is 4. That is placed here. So this is how you obtained the default rank in a data frame. Okay, suppose we are giving this command method equal to max, which means rather than fixing a average value as in your previous case, we have found out average. If both the number of legs are equal, we have assigned equal rank for both. But if you are giving like this rank method equal to max, which means among these two, what is the maximum rank? 3 is the maximum rank. So you need not take average and give or assign for both of these values. Instead, you of setting an average value, you keep the maximum value. So the position value is 3. So that value will be assigned for both of these 4 number of legs. So for 4, you have 3, 3, and 2, you have 1, and for 8, you have 4. And this is how you find out the maximum rank. Okay. Okay, so if in case you give NA option, if it is not a number, then you assign the bottom value. Okay, what is the bottom value? Bottom value means highest rank. Okay, so that rank you have to assign for NAN. Okay, so what happens here? In this case, for NAN, your position value is 5, hence the rank value also will be 5. So rather than assigning NAN here, you are assigning 5. Okay, so this is the use of going for this particular function. So if it is a NAN option, you assign the highest value or the bottom value. Okay. So then comes the PCT rank or the percentage rank. Okay, so percentage rank, if you set this field as true, okay, then the percentage rank will be calculated as follows. See, first the rank value is found out. Leave the NAN value. What is the highest value? 4 is the highest value. So the particular rank value divided by the highest rank value. So 1 by 4. Here 2.5 divided by 4. 2.5 divided by 4. 4 divided by 4. Leave NAN. Okay, so NAN does not comes into picture here. Okay, unless we explicitly define NAN option, what to do with NA option. Otherwise, it is always maintained as NAN. Okay, so 1 by 4 is 0.625, 2.5 by 4 is 0.25. So similarly, these are calculated as the percentage rank, and if you give like this, the percentage rank is calculated and displayed as below. Okay. So various methods and the calculate after calculation, if you print all of these, the data frame look like this. Okay. Next comes the sorter. See, sort is sorting the values along the axis. So see, you can sort the data frame based on one or more columns. Okay. So we will have to use ascending parameters to sort the order. Okay. So so we can also organize or deal with NaN values even in the place of sorting. Okay. So if you want to sort in a particular order, you use ascending equal to true or descending equal to true. Okay. Okay, so this is actually a data frame created. So you have all these countries names, year names, some values associated. Also, continent names are given here. Okay, so then all these values are converted into a data frame, and if you print the data frame looks like this. Okay, so suppose if you want to sort it based on the ascending values of the country. Okay. So what command you will use? So df dot sort values by equal to country. Okay. If you do not mention ascending or descending, by default it sorts in the ascending order. So what happens? All the country datas are sorted in the ascending order and the corresponding year and populations are populated in the data frame. Suppose if you want to sort it in the descending order, then what happens? You type it as, or you place ascending equal to false, which means descending equal to true. But here we would wish to sort based on the descending order of population. So population, starting from the highest value to the least value, the values are arranged and the corresponding country, year, continent and the position values are swapped and the data frames are displayed like this. Okay.